In this lesson, we're going to be solving this problem statement. So this problem statement is under hydraulic system. So here we are required to find this Chezy's coefficient. We are required to find the hydraulic mean depth. This we are required to find the hydraulic gradient, which is I, this one. And also we are required to find the value of the coefficient of the friction. And we are given the condition that we must use the Chezy's formula here, whereby here we'll be using when we find the Chezy's coefficients, we'll be using Chezy's theory, and also here we'll be using Chezy's, and also here we'll be using Chezy. Only here where we'll be required to find the coefficients of the friction, we'll be using Chezy's formula. So let us write the data that we have from this problem. We have the flow rate here. It is 25 liters per second. Here the flow rate that I'm talking about. Then we have the diameter of the pipe, which is 95 millimeters. And we have the pressure. It is 50 times 10 to exponent 3 Pascal. And also we have the length, which is 20 meter. Then let us convert this flow rate into cubic meter per second. We'll do it here. It is 25 liter per second. Then 1000 liter is equal to 1 cubic meter. Then this, the liter cancel. The answer to be 0.025 cubic meter per second. The diameter here, it is 0.095 meter. Then this pressure, we have already converted it into Pascal. Let's see now how to find these coefficients of the friction, which is represented by a letter F like this. We'll use Chezy's formula. Chezy's formula is, it is H to a subscript F is equal to coefficients of the friction that we are looking for times the length times the flow rate, all divided by 3.026 times diameter to the power 5. That is Chezy's formula. We are looking for these coefficients of the friction. Then we'll make this F that we are looking for a subject of this formula. Then it's gonna be that F, coefficients of the friction, then it is equal to HF times 3.026 times the diameter to a power 5, all divided by length times the flow rate squared. It is like this. Here we have the diameter, we have the flow rate, then we don't have this HF. This HF, we don't have it. To find this HF, we will use this formula. HF is equal to P divided by a rho times G. That's the formula we are using to find this HF, of which is a loss of head due to friction. Our pressure, it is 50 times 10 to exponent 3, then divide by the density of this liquid, it is 10 to the power 3 times the gravity is 9.81 then this it gives us 5.1 m. That is the loss of head due to a friction. Now we have found this HF. Then let us substitute to our formula. It is at coefficients of the friction. Then we put this 5.1 times 3.026 times the diameter. Here it is 0.095 to a power 5, all divided by the length. The length is 20 meter times the flow rate. We converted it here. It is 0.025 squared, 0.009. That is the coefficient of the friction that we have been looking for here, this F. Then we find the coefficient of the friction, that is A. Then we proceed to B. The B say we must find the Chezy's coefficients. Then before we find Chezy's coefficients, we have to find this C, which is M, the hydraulic mean depth. Let us find the hydraulic mean depth first and the hydraulic gradient, this. Then after we found these two, the hydraulic gradient and the hydraulic mean depth, then we go back to find this. Let us find the hydraulic mean depth. It is, because this is a circular pipe, we'll use this formula. It is M is equal to a diameter divided by 4. Then our diameter here it is 0.095. Then we get 0.024. That is the hydraulic mean depth that we have been looking for. Then let us proceed now to find the hydraulic gradient, which is I. To find this I, we have to use this formula, which have the HF divided by the length. That HF that we have found here on top, this one, HF, it is 5.1. That HF is 5.1. This one divided by the length of which is 20, 0.255. That's the hydraulic gradient. Then we have this I, we have M. Now we can find this coefficient, which we can find it using this formula, which is the velocity is equal to this C, which is the Chezy's coefficient, and the square root. Inside the square root, it's M times I. This formula that we're gonna use to find the Chezy's coefficients, this one C, this one. Then let us take this formula down here. It is V is equal to Chezy's coefficients square root, then hydraulic mean depth times the hydraulic gradient. Then we're looking for this part. Let us make it a subject of the formula. It is C is equal to V divided by square root M times I, like this. Then you substitute here. But before you substitute here, remember you don't have this velocity. You have to find the velocity first. To find the velocity, let us find it here. We will use the flow rate equation, which is from the continuity equation. We're gonna say Q is equal to area times velocity. That's the velocity we're looking for. Velocity is equal to a flow rate divided by area. So the area, we'll write here the area, it's pi. Then our diameter here is 0.095 squared. Is our area. Take this area, go back to put here this formula. Our flow rate was we converted it here. It is this 0.025. Put it here 0.025, then times 4, all divided by pi, then 0.095 squared, like this. 3.57 meter per second. That is the velocity. Take this velocity, you put it here in this formula. Let us proceed here. It is 3.57 divide square root. The hydraulic mean depth is here. It is, we put it down there. Then the hydraulic gradient here, it is 0.255, like this. Then 45 point F, found it. C, found it. M, found it. I, you found it. Then I, 0.255. M, where's M? 0.024. Chezy's coefficient 45.769. Then this F, coefficients of the friction. Then you found it here, 0.009.